Okay, we're going to look at number 89 that was asked about in class. So this question was to determine whether this function right here was differentiable at 2. Okay, so we want to check whether it's differentiable at 2. Now, just a quick note, one of the things that you might want to do, and I've already done this, I've already checked this, but I might want to check that this thing's continuous at 2. The only reason I say that is checking the continuity at 2 is really quick, right? And the reason I say that is both of the functions themselves are continuous everywhere. But if I plug in, it's really easy to plug in 2 to both of these equations. Right? If I plug into the top equation, I get 4 plus 1 or 5. I plug into the bottom one, I get 8 minus 3, which is 5. And the only reason I say that is if it had not been continuous at 2, then I could say it's not differentiable and I could move on. So checking the continuity was so quick and easy that it was probably worth just checking really quickly, because if it had failed, then I could say, nope, not continuous, therefore not differentiable. But no, I'm not going to be able to. I'm going to have to go a little bit further. So what I'm going to do is I'm going to use the limit definition. I'm going to use the alternate form of the derivative here. So in other words, I'm going to take the limit I'm going to take the limit as x approaches c from the left and from the right. So in this case, if I go from the left, right, I'm going to be using the top function. I'll be using x squared plus 1. So let's do that. So that's going to be f of x, which is using fingerprints. So x squared plus 1 minus f of c, which is 2 squared plus 1. And that's going to be all over x minus c, or in this case, x minus 2. And by the way, I know I put a c. Let's change that to a 2. Let's be specific. Okay, and then what I want to know is that equal to, so I'm going to put an equal sign, but maybe a question mark, because I don't know if that's true or false. Is that going to be equal to as it approaches from the right, which is the limit as x approaches 2 from the right of the bottom equation now, right? So it's going to be f of x, which is 4x minus 3, minus f of c, or in this case, f of 2, which is 4 times 2 minus 3. Right, so the question really becomes, actually, I had too many parentheses there. All over, sorry, let me just finish that up, x minus 2. Because the question really is, right, are those limits the same? And the alternate form of the derivative is really good to check that, because if the limits aren't the same, then this thing doesn't work. So let's see what we got here. So continuing on, I get the limit as x approaches 2 from the left, and that's going to be x squared plus 1 minus, what is that, 5, looks like, all over x minus 2. And again, is that equal to the limit as x approaches 2 from the right of 4x minus 3 minus 8 minus 3 is 5. So over 5. X minus 2. Let's keep on going here. Let's see what we get. So I get the limit as x approaches 2 of x squared. Looks like minus 4, right? That's nice. And again, is that equal to the limit as x approaches 2 from the right, which is going to be, is that 4x minus 8? Yeah, it is 4x minus 8. Okay. Over x minus 2. So kind of a longer problem. So here I get x plus 2, x minus 2 over x minus 2. And again, is that equal to the limit as x approaches 2 from the right? I'm going to pull out a 4 there, so I get x minus 2. Oh, look at that. How convenient is that? So as you noticed, and I noticed, I got an x minus 2 that cancels out here and here, and I'll have an x minus 2 that cancels out there and there. So, continuing. What do we get? We get the limit as x approaches 2 from the left of x plus 2. And the question is, does that equal the limit as x approaches 2 from the right of 4? So doing this, I plug in 2, I get 2 plus 2. And the question is, does that equal 4? And I think you guys would agree. Yep, those two things are equal. So what is my conclusion? My conclusion, excuse me, I'm going to shrink this out just a little bit. But my conclusion is that f of x is differentiable at x equals 2.